So today we're going to be looking at arithmetic series. So last time we talked about an arithmetic sequence. So let's look what so let's say we've got 1, 4, 7. This is an arithmetic series. It's going up 3 every time. So the next number would be 10, then it'd be 13. This is the arithmetic. This is where my spelling goes horribly wrong. Sequence. Okay? This is a sequence. Now, an arithmetic series is when you take the terms and you add them. So 1, add 4, add 7, add 10, add 13, and so on. This is an arithmetic series. We learnt last time that the general rule for an arithmetic sequence, so let's say that, so this is n, this is the term number, so this is term 1, this is term 2, this is term 3, this is term 4. So if we wanted, so I'm just going to call term an, so this is n, so say we wanted term 3, that would be 7, so an would be 7, is a, the first number in the sequence, plus n minus 1 times d, where d is the difference. In this case it would be 3. So this was the general rule for the sequence. So today we're going to find the general rule for a series. Now, the way we're going to do this is, let's consider let's write our formula for the arithmetic sequence up here. So we've got an equals a plus n minus 1 d. Okay? Now, up here we're going to write n, so this is the term numbers. We've got 1, we've got, can't count, that's not good, 2, 3, 4, 5, 6, and so on until we get to n. And here we've got the terms in the sequence. We've got an, so the first one's going to be a, then the next one is going to be a plus, now it's n minus 1, which is 2 minus 1 is 1, so it's just plus d. Then the next one is going to be a plus 2d, and so on and so forth. And then up here we're going to have a plus n minus 1 d. Now, what we're going to do, if we were doing an arithmetic series, so the notation for that would be Sn, and we would add all these terms together. Okay, so this is sum. So we're going to rewrite this as being Sn, but we're going to rewrite the series but in the opposite way. So instead of starting at the first term a, we're going to start at, I'm going to rub that bit out because it's going to be, it's getting in the way. There we go. So the sum, the series, is each term added together. So we're going to rewrite the sum of our series, but instead of starting with the first term, we're going to switch it round. So we're going to have a plus n minus 1 d plus a plus, and it'd be n minus 2d plus all the way up to up here would have a. So this will become clear in a minute. What would happen if we added this to this? So let's add them. Add each term together. So we're going to have 2sn equals 2a, we've got 2a plus n minus 1 d, because I'm going to change colour so we can see what we're going to add each time. Let's change colour to this one. So here we've added this bit. Now next we're going to add this bit here, and we will end up with what colour was I doing this in? The nice yellowy colour. Okay, so here we've got plus a plus d plus a plus n minus 2d. Now that looks messy, we'll come to it in a minute. And then right at the end we will have our 2a plus n minus 1d. Now we're going to tidy this up. So we've got our 2a and we've got n minus 1d here. And here we've got plus 2a and we have plus, now let's break this open. We've got nd minus 2d from here. We've got we're going to add this extra d here. And then we've got way over here, we've got 2d plus n minus 1d. So this term here is going to become, I'll just rewrite this all out, minus 1d plus 2a plus, now minus 2d plus d is minus d. So we've now got, we've come back to n minus 1 d plus 2a plus n minus 1 d. So what we have is this term is the same, it's being repeated. So we have n of these, we have n times 2a plus n minus 1d. Now I'm going to put this in a square bracket so we know it's different. Now we can simplify this down. Remember this is 2sn. We can now rewrite this as dividing both sides by 2, sn is n over 2 and it is 2a plus n minus 1 d. And this is the general formula for an arithmetic series. So the sum, remember we talked about how a series is the sum of all the terms in an arithmetic sequence. The sum, the arithmetic series is the number of terms within the sequence. A is still the first term in that sequence and D is still the difference between the terms in the sequence. Let's see how this will work in an example. I'm going to write this formula that we've just derived, Sn equals n over 2, 2a plus n minus 1 d. Now you would be, in the IGCSE exam, you are given this. The arithmetic sequence formula, which I'm going to write as A plus n minus 1 d. This one you need to memorize. This one you are given. Okay, so we're just going to keep these up here because we want to refer to them. Now, so the first term we can call it A1 in an arithmetic series is 40, and the common difference is a half. Find the sum of the first 21 terms. So we need this formula here. So we've got Sn n over 2 2a plus n minus 1 d. So let's remind ourselves what the symbols mean. So n is the number of terms, so that's 21. In this case, we're given the number of terms. A is the first term, so it's going to be 2 times, what was the first term? 40. Plus, now it's n minus 1. N minus 1 here is going to be 20, because 21 minus 1 is 20. So it's going to be 20 times d. Now that's a common difference times. Now I'm going to put this in a wee bracket so we know it's a half, minus a half, so we don't think it's a subtraction. And then we basically you just go through the arithmetic, you do the arithmetic. So we're going to have 10.5 times 80 minus 10, which is 735 is the sum. It was a nice simple one. Now, if we are given, so that the next example is the 6th term of an, I'm just going to call it arth for arithmetic, and its series is 20. The 11th term in the same series is 35. Find the sum of the first 100 terms. So we know the nth term is a plus, so that's a1 plus n minus 1 d. The sixth term is 20. So let's write that in. So let's say, so we know 20 equals, we don't know what the first term is, plus n minus 1 here is 5, and we don't know what the common difference is. We also know that the 11th term is 35, so we're going to set up here a simultaneous equation. So we've got 35 equals a1 plus, this time the n minus 1 term is going to be 10 d. So these are the same, so let's just subtract these two simultaneous equations, and we will get 5 minus 10 is going to be, we have minus 15 equals to minus 5d. The minuses cancel out and we're going to end up with d equals 3. If we then plug that back in, we'll plug it back into the first one, so 20 equals a1 for the first term plus 5 times 3, which is 15, and then we're going to find a1 is going to be 5. So now we know the missing terms that we didn't have before. So here we now take Sn equals n over 2, 2a plus n minus 1 d. We know all these different pieces of information, so we just slot them in because we want to find S for the first 100 terms. So it's going to be 100 over 2, 2 times a is 5, is going to be 10, plus 99, because n minus 1, times d, the difference was 3. If you do the calculation, put it into your calculator, it's going to be 15,350. So that is arithmetic series. I hope that helps. Yeah. If you've got any questions, let me know.